Hello everyone. I would like to present today all of you our paper titled Enhancement of Design and Manufacturing Capacity of Francis Turbine in Nepal. So throughout the paper I will be introducing you about the what actually the Francis turbine is. Then we will be discussing about the problems that are being encountered during the development of this kind of turbines. Then we will discuss different kind of methods and technology that are being used to manufacture this kind of turbines. We'll discuss some challenges that may arise during manufacturing of this kind of turbines in the underdeveloped countries like Nepal. And finally, we will be summarizing the presentation. So, introducing you all about the Francis turbine. It was developed by James B. Francis and it was named after him. It is used widely in most of the hydropower stations around the globe due to its higher efficiency rate. It can work for the head from 3 to 400 meters and it has higher durability too, and due to its wide range of application it is being used by most of the hydropower stations around the around all of the continents. So the purpose behind this study is to study different conventional and modern manufacturing techniques of the turbines, and also to study if there is any possibility of designing and manufacturing Francis turbine in Nepal. So talking about the problems, design enhancement and development of sustainable manufacturing process of hydro turbine has always been a new trend in hydropower industries nowadays. So new concept of combining these different kinds of application like CAD, CAM, CNC, and using different simulation software has always got some promising result. So what actually are the problems for the underdeveloped countries like Nepal are the technical and maintenance issue after importing this part due to the lack of the technicians to maintain if there is any breakage of the parts always leads to the unwanted shutdown of the hydro stations. That's the main reason behind the country wants to stay forward for in-house production of this kind of turbine. So if the country is taking a step, then the big question to be answered arises: which level of manufacturing techniques are available and affordable by the underdeveloped country like Nepal to meet the standards. Now let's discuss about the different methods and technology that are being used to manufacture this kind of turbines. So casting, pressing, these two are the old manufacturing techniques that are being used for manufacturing these kind of turbines. Now in the modern days, CNC machining is highly preferred due to its accuracy to develop the runner blades, and after the manufacturing, the work must be verified, so CFD analysis is further done and further mechanical analysis is being carried out, and finally they will move forward for the final manufacturing. Talking about the casting, it is widely used manufacturing techniques around the globe for the centuries, and due to the complex geometry of the blades, investment casting is preferred for manufacturing the turbine blade. So there was also attempt made by the Kathmandu University for the single piece casting of the turbine, and the first attempt of the casting was not successful, but later the defects are removed after studying the possible reason for the failure, and finally a single piece casting was done successfully. So pressing is also widely used for manufacturing the turbine blades, and this technique is used to produce the part with the higher mechanical properties. So due to the more strength and less manufacturing cost, pressing is also used to manufacture the larger blade. And CNC machining, talking about CNC machining, it is the modern manufacturing technique, though it may result some further higher cost, but due to the accuracy and the other efficiency reasons, it is being highly used for manufacturing the turbine blades. So talking about the challenges, what are the challenges our country may face if we want to step forward for manufacturing this kind of turbine blades? So the existing manufacturing techniques and the manufacturing industry, it may be hard for them to meet the complex profile of the blade, and which may also arise the question of efficiency and durability. So, so far as I'm concerned, the modern manufacturing techniques are not entertained by the Nepali manufacturers till date, because due to the lack of the technicians, because due to the lack of the person who can use the modern CNC machine and these techniques, still they rely on the old manufacturing techniques. But if the country come up with some good policy and regulations, and if they are uh, successful to manufacture their own blade, then there may also arise a question of repeatability. So if one of the turbine of any hydrostation is needs to be changed, and country just manufacture it, and then after some period of time, if it needs to be changed, so are the manufacturers able to manufacture the same piece after that time? So that may be also the challenges that we must overcome. And finally, it will come to the cost. So what may be the cost importing these all kind of techniques, and if we want to manufacture it within the country? So finally the cost will also matter in this kind of issues after all. So now I like to conclude my presentation. So Nepal has a huge potential of generation of hydropower industry, and some serious major steps need to be taken to meet the future energy demands. So with the better policy from the government of Nepal, we can move a step forward in in-house manufacturing of the turbines. Different group of motivated engineers and researchers have come up with different proposed design and experimental result to overcome the challenges that are arising due to the geographical location of the country. So they must be encouraged, and introducing the different problems that may arise due to the geographical location as design parameter. As I discussed already, the problem may arise according to the different geographical location. The location of the country is also responsible to uh, to arise some different kind of problems. So that's all for today, and I would like to express my special thanks of gratitude to Assistant Professor Mr. Shrestha, who provided me the opportunity to work on this project initiated by Energize Nepal. And finally, I would also like to thank my friend and colleague who assisted me throughout the period. Thank you all for bearing with me.